Hello students, welcome to EduWave online classes. So today we are going to learn power, but before we start, I request all of you to kindly subscribe our YouTube channel and follow us on WhatsApp. The link for the WhatsApp channel will be provided in the description box along with this video. So without further ado, let's start. So as you see, the topic written on the board is power. So what is power? The rate of doing work. Rate of doing work is called power. Now what do we mean by this statement, rate of doing work? So power is equal to work done upon time taken. That means how much amount of work we are doing and in how much time we are doing. That gives us the value of power. This is the mathematical expression for power. Okay. So now we come to the SI unit of power. Now we know that in our last video we have learned about this work. So the SI unit of work done is joule and the SI unit of time is second. So the SI unit of power is joule per second. Now this concept of power was discovered by James Prescott Watt. So after him, the SI unit of power is watt. It is denoted by symbol capital W. Now, what do we mean by 1 watt power? What do we mean by 1 watt power? It is nothing but if 1 joule of work is done in 1 second, then power spent is 1 watt. That means if 1 joule of work is done in 1 second, then we say that 1 watt of power is spent. Now similarly, like this, SI unit of power is joule per second or watt. The CGS unit of power, you all tell me what will be the CGS unit of power? See, the SI unit of work done is joule and the CGS unit of work done is what? Arg. And the SI unit and CGS unit of time remains the same, it is second. So the CGS unit of power is arg per second. Some of the time it is also written like arg s to the power minus 1, right? Now this is the standard mathematical formula for power. There is also another mathematical formula which might be used a couple of times for solving certain numericals. Now let us see what is the other formula. So work done is nothing but the dot product of force and displacement, and time remains in the denominator as it is. Now, from the chapter of motion in one dimension, we know that change in displacement with respect to time or displacement by time can be written as what? Velocity. This term, displacement upon time, can be written as velocity. So another mathematical formula for power comes out as force into velocity. This is another mathematical formula for power. Okay. Now we will be learning the differences between work done and power. So let's go. Now let's see what are the differences between work and power. So we make two columns. Over here we write down work On the right side, we write down power. Now, the first point of difference will be their definitions. That is, product of force and displacement. Is known as work done. Now, for power, what we can write the definition? For power, it is rate of doing work is called power. Now, second, their mathematical expressions. That is, work done is equal to the dot product of force and displacement. Here, the mathematical expression of power is work done upon time. Okay? Number 3, here in this mathematical expression for work done, we find that work done is independent of time. So, work done is independent of time. Whereas in the mathematical expression for power, we see that in the denominator we have time. So power is dependent on time. And the last point of difference is their SI unit. So the SI unit of work done is joule. The SI unit of work done is joule. And the SI unit of power is, SI unit of power is what? Tell me. It is watt. So some of the times in your exam, you might find this question. State some point of differences between work and power. So here is the list of differences between work and power. Now, there are some other bigger units of power as well. Some bigger units of power as well. Now, what are the bigger units of power? First is 1 kilowatt. That is equal to 10 to the power 3 watt. Because kilo stands for 1000, that is 10 to the power 3. 1 megawatt. That is 10 to the power 6 watt. And 1 gigawatt. That is 10 to the power 9 watt. So these are the 3 bigger units of power. Now, another unit of power is used in mechanical engineering, especially in order to measure the power of, in heavy machineries. So that is horsepower. That is horsepower. Now, what is the relation between horsepower and the SI unit of power? That is 1 horsepower is equal to 746 watt. And if we want to express this in kilowatt, so we get 1 horsepower is equal to 746 divided by 1000. It gives us 0.746 kilowatt. Both these relations are correct. And this horsepower is specially used in mechanical engineering, okay, for measuring the power of heavy machineries. Now, in the first video, I told you that work done is the dot product of force versus displacement. Now, one thing I would like to tell you, that if we plot a graph of displacement versus force, if we plot a graph of displacement versus force, we take displacement along x-axis and we plot force along the y-axis. Now suppose the graph of force versus displacement is like this, right? That means as you keep on increasing the force, the displacement is also increasing proportionally. So in such a case, suppose the question is given, you have to find out the work done from this force versus displacement graph. How do we find it out? Now we drop a perpendicular line, and we calculate the area covered under this graph with the x-axis. We calculate the area covered under the graph along with the x-axis. Now this we can see is a triangle. So we know that formula for area of a triangle is half base into height. Now suppose this is 0. Suppose this is 5, okay, displacement, so it will be 5 meters. And suppose the body has been displaced by 5 meters under the application of, let's say, 20 Newton force, right? So the base of this triangle is how much? 5. So let us replace half, base is 5, and the corresponding height is how much? 20, and the SI unit of force is Newton, so that is 20. So 2 cancels 20 10 times, so 10 5s are 50 joule of work is done. So this is how we calculate the amount of work done from force versus displacement graph. We calculate the area covered under this force versus displacement graph. That gives us the value of work done. Now so far we have learned the theoretical concepts, the graphical part of work done and power. Now let us do a couple of numericals based on that. I would take one simple numerical, a boy of mass 40 kg. So the first method of doing numericals in physics, whatever data are given in the question, first let us note down. Mass of a boy is 40 kg. Okay. He climbs up the stairs and he reaches on top of a roof that is 8 meters high. Okay. So the height is 8 meters up to which this boy has gone, and the time taken is 5 seconds. So time taken is 5 seconds, right? Now the value of acceleration due to gravity, that is small g, is given. How much? Now the exact value of small g is 9.8 meter per second square, but some of the times in order to simplify our work for these numericals, we take it as 10 meter per second square. That will be mentioned in the question, g equal to 10 meter per second square. If it is not mentioned, then please do not take it as 10, you take the exact value 9.8. But here it is already given in the question, 10 meter per second square. So these are the data. Mass is 40 kg. He climbs up a height of 8 meters in 5 seconds, and acceleration due to gravity is given 10 meter per second square. First, the force of gravity acting on the boy. Number 1. So we know that force of gravity is nothing but the weight of the boy. Now weight is nothing but the force with which the earth attracts the boy of mass 40 kg. So force of gravity will be 40 into the value of g is given how much? 10. So the gravitational force acting on the boy, or the weight of the boy, is 400 Newton. This is number 1. Number 2, we have been asked to calculate the work done by him against the force of gravity. Now, yesterday in our first part, I taught you that the boy is going upwards. That means displacement is directed upwards. whereas the force of gravity on the boy is acting downwards. That means displacement is in this direction, force is in this direction. So what is the angle between them? 180. So I told you that if the angle between force and displacement is 180, then negative work is done. So work done is given as what? F S cos theta. So let us put the values. So force means this one, 400. What is the displacement of the boy? That is 8 meters into cos. In place of theta, we are going to put 180 because force and displacement are directed opposite to each other. In the last video, I also told you what is the value of cos 180. That is -1. So work done, 400 into 8, 8 fours are 32 and 2 zeros with a negative sign because -1 into 3200, that is 3200 joule. Now here we need to specify that negative sign indicates that force and displacement are at an angle of 180 degree with respect to each other. Okay, so we need to mention this, that negative sign indicates that displacement is upwards and force, gravitational force, is acting downwards. Number 3, we have been asked to find out the power spent by the boy. So power is how much? Work done upon time. So how much amount of work is done? It is 3200. Now over here, please do not put the value as negative because negative, I told you that the value is not negative. Negative just signifies that force and displacement are at an angle of 180 degree. So we will put it as 3200 upon, in how much time he has gone? 5. So if we calculate this, 5 6 are 30, 20, 5 4 are 20. So power spent by the boy is 640 watt. Now we will be moving on to our second question. So it is given that a pump is used to lift 600 kg of water. Okay, so the mass of water is 600 kg from a depth of 75 meters. So depth is equivalent to height. Okay, 75 meters in 10 seconds. So time taken is 10. So first of all, we have been asked to find out the value of work done. And we have been asked to take the value of small g as 10 meter per second square. So work done under the force of gravity. Okay. So a pump is used to lift water. That means the force is applied in the upward direction and the body is also going up. So work done by gravitational force, yesterday we have learned that it is mgh because mg is equivalent to force and h is equivalent to s, that is F dot s. So work done will be how much? 600 into 10 into h, that is 75. So 6 5s are 33, 7 6 are 42 and 3 45, 1 2 3 into 10 to the power 3 joule. So if you combine this, we get, so in order to, even if you keep the answer like this, it is very okay, no problem with that. If we want to express this in the standard form, we divide this by 100 so that over here we get 4.5, and all of a sudden, since we have divided by 100, we have to multiply by 100 as well. So 10 to the power 3 into 100, that is 10 square, gives us the value of work done as, 10 to the power 5 joule. Both these are correct. It is not necessary that you have to bring it in this form. You can also keep in this form. That is very fine. Number 2, the power at which the pump works. That means they have asked you to find the input power. Input power. So power is how much? Work done upon time. Okay. So how much amount of work is done? This much. 450 into 1000. And in how much time this work is done? 10 seconds. So 1 0 cancels 1 0. 45 into 10 to the power 3. Okay, that is 45,000 watt, or we can write it as 45,000 watt or 45 kilowatt. This is the power at which the pump works. Okay. Now, number 3, the power rating of the pump. If it's efficient, this is output power. Power at which the pump works means this is the output power. Okay. Number 3, efficiency is output power upon input power. Output power upon input power, this ratio is efficiency. And in the question it is given the efficiency of the pump is 40%. Okay, so 40%, if we want to convert in fraction, we divide by 100. Now, output power is how much? 45,000 watt by input power. So, from here, 40 into input power equal to 45,000 into 100. So, input power is equal to 45 into 1000 into 100 by 40. So 0 cancels 0, 4 25s are 100. Now, so if we further simplify this, we get the value of input power as 112,500 watt, and if we divide by 1000 we get in kilowatt, that is 112.5 kilowatt. So now, because see, there is no such machine in real life where the output can be more than the input. Even in ideal situation, output and input are equal, because whatever we give as input, a part of that is converted into output. This we will learn further when we learn machines, efficiency in machines. So here output power, that means the power at which the pump works, is 45 kilowatt, whereas we have given an input of 112.5 kilowatt on this machine. So I hope this video makes it more clear, and let us do one more numerical based on the last concept that I have taught you, that I have taught in today's class. Now this is our last numerical for this class, okay, where we will be utilizing another mathematical formula that I have taught you. Okay, the power of a motor is 40 kilowatt. Fine, so we note down 40 kilowatt, that is equal to 40,000 watt. And at what speed the motor raise a load of 20,000 Newton? Load means force. 20,000 Newton. Now, once more, I remind you that today we have learned two formula for power. One is work done upon time, this is number one, and number two, power is force into velocity, right? Now here we have been asked to find out at what speed can this motor raise this load. That means we have been asked to find this V. So definitely we will use this second formula. So if we want to find V, that is nothing but power divided by force. Now what is the value of power? 40,000, it was given in the question, by what is the force it has to lift? Load 20,000. So if we cancel this one, we get 2. So 2 meter per second is the speed at which the load is raised. So I hope you have understood this concept of work and power. All the formulas that we have learned, we have utilized over here, and in our next video, which will be uploaded very shortly, we will be learning the concept of energy. Till then, keep studying. Wish you all the best. Thank you. Bye bye.